I want to talk through the Excel solution to the practice residence time problem. So here's the full solution in Excel with everything completed, and I'll talk about how I got these different numbers and the procedures I used to do this. So first thing I want to note about when I use Excel to solve a problem is I always list the variables clearly showing their units. So in column A, these are all variables that I'm going to use with the units attached. That's really important in Hydro. And then I have the values. Now, the reason they're in yellow here, these represent the values that were given, the problem gave us. And by implication, then, everything else is a calculation. So the value, for example, here in cell B11, that must be calculated because it wasn't a given value. These are just numbers I entered. These were the data I was given for the problem, which included the area of the lake in meters squared, the average depth of the lake in meters, the evaporation rate in inches per year, that's English unit, precipitation rate in inches per year, and then the inflow and outflow stream flow in the metric unit of cubic meters per second, and the groundwater flow in the metric unit of cubic meters per year. So there's obviously a whole bunch of unit conversions that are going to have to happen here. So the first thing I wanted to do here, I need to actually create, remember for this balance, my expression for the residence time is going to be the volume divided by the flux in or flux out in volume per time. So the first thing I need to establish is that we're at steady state, so the inflows and outflows are the same. So the inflows will consist of, let's actually use, I'll use red here to show you the inflows. The inflows are going to be precipitation, that's an inflow, and stream flow in. And the outflows, I'll use green. The outflows are going to be stream flow out. And groundwater flow in should have been that should have been an inflow as well, right? So the inflows in red are precipitation, stream flow in, groundwater flow in. The outflows in green are stream flow out, and there it is, evaporation out. Oops, wrong thing here. Okay. So just keep track of the inputs and outputs here. Now notice that in order to do this, all the inputs and outputs need to be in a volume per time. But as we've discussed earlier, the evaporation and the precipitation are given as rates of length per time. And so I will need to multiply them by the area of the lake. The area of the lake is given in cell B3. But the area is given in square meters. The evaporation and precipitation rates are in inches per year, so I need to convert those into meters per year so that when I multiply them by square meters, I will get cubic meters per year. That's going to be the coin of the realm here when I do my calculation. So the first thing I want to do is here in this cell B11 here, I've converted, in B11, I'm converting the evaporation rate in inches per year to meters per year, and I'm doing it using Excel's built-in convert function. This is really cool. All I need to do is say equals, this is a function convert. I give it the value I want to convert, and as always, I never type in the number. I give it the cell where the number is found. So this reads, convert the number that's in cell B5, that is the evaporation rate in inches per year, from inches in parentheses in quotes to meters in quotes. And when you actually enter this equation, let me show you how it works. It'll actually show you the possible units that it knows. So if I were to type this in, I go equals convert the number in B5, okay, and then I hit parentheses, and these are all the things it knows how to do. And if I know that it knows inches, so I type inches here, and it immediately knows now I'm talking about length, and these are all the other lengths that it can convert inches to. I could convert it to nautical miles or picas or light years or parsecs, but in this case I want just plain old meters, which is the first one on the list, which is just M. So this converts my evaporation rate in inches per year to meters per year. That's what's found in cell now B11. And to get the the volume flux, and I'm going to use a kind of symbology here that is common in hydro. I want to make it clear that I mean all these terms have to be in volume per year. So I'm going to use mu sub E. Can you read that? Mu sub E. Mu means volume per year, volume per time. So mu sub E means the evaporation rate in volume per time, specifically meters cubed per year. And I'm going to get that by multiplying the evaporation rate in meters per year here times the area of the lake in cell B3 in square meters. So square meters times meters per year gives me cubic meters per year. So that's what I did here. I just multiplied those two numbers together to give me the flux, the outflow of water due to evaporation in cubic meters per year. Now I'm going to follow exactly the same steps to calculate mu sub P, that is the inflow in terms of volume per year due to precipitation. I'm going to first calculate the precipitation rate in meters per year by converting, look at the equation here, I'm converting the value found in cell B6, which is in inches, from inches to meters, and there I go, that calculates it in meters per year. And then I multiply the rate in meters per year times the area to give me mu sub P, or the flux in volume per time of water due to precipitation, P in meters cubed per year, which is 1.75 times 10 to the 8th. All right, so that takes care of, so now at least all our terms are in volume per year. Groundwater is already given in meters cubed per year. Let's just make a point of that, meters cubed per year. What I'm going to do in these kind of columns in D and E, the one in kind of yellow and blue, is I'm going to keep track of all my inputs and outputs. When they are in, I'll make this clear, when they're in meters cubed per year, I just can't enter them until I've converted them or made them into meters cubed per year. Now, groundwater flow is already in meters cubed per year, and it's an input. So I just copied it over here. I just look at my equation. I just say, take the value in B9 and put it over here. Now that I've calculated precipitation rate, that's another input in cubic meters per year, I can copy that into here too. Notice what I did. I just said, take the value that was B14 and put it over here. So that's an input and that's an input. The evapotranspiration is an output, so I just copied that value into the blue column, right? That's the output in cubic meters per year due to evapotranspiration. And what I'm left with here are my stream flows. Now my stream flows are given in volume per time. That's good, but they're not in meters cubed per year. They're in meters cubed per second. So I need to convert these to meters cubed per year. I'm going to show you two different ways to do it. Let me get rid of this formula here, and I'll just enter it here. So if I want to take this number, it's going to give me some, where is Q? This is Qn. So Qn right there is 11.29 cubic meters per second, and I want to convert that to meters cubed per year. So what I'm going to take the value in that cell in B7, right? That's meters cubed per second. And now I need to multiply that times the number of seconds in a minute, which is 60, times the number of minutes in an hour, which is 60, times the number of hours in a day, which is 24, times the number of days in a year, which is 365. And when I do that, I will have calculated the amount of meters cubed per year. It's going to be a much larger number. There it is. Now there's another way to do this, and it's really clever. It uses the convert function. I'll show you how that works here. Let me just get rid of it here. So now I'm trying to convert the outflows due to stream flow. There's a stream flowing out of our lake, and there's the outflow in cubic meters per second. It's 12.22, right? So this is in cubic meters per second. Second is in the denominator. So what I'm going to do here now is I'm going to use the convert function like this. I'm going to say this is equal to B8, that's the outflow in cubic meters per second. And now I want to convert those seconds to years using the convert function. But because it's in the denominator, I have to remember to divide by the convert function. So I want to now convert 1 second, see that 1 second, and it'll tell me these are all the things that can convert 1 second into it. I can convert seconds into minutes, hours, days, or guess what? YR is years. And so let's look at what I did here. I took this number and I took the number in cubic meters per second and I divided that by the conversion of seconds to years, and that will give me cubic meters per year. How easy is that? Whoops, what did I need to do here? Oh, convert. Oh, I didn't look. You know what I didn't do here? I didn't, I have to put years in parentheses, in quotes. I didn't put my first quote. See it there? Okay, very, very persnickety. There we go. All right, so now I'm just going to copy those over into our columns here. So the input I'm going to copy into our yellow inputs column, and the outputs here I'm going to copy into the outputs column. So now everything in yellow here were inputs, everything in here in blue was outputs, and I can use Excel's sum function. You see how this works? I'll erase it here just to show you how it works. I can say, whoops, I didn't mean to do that. Let's go back here. So what I can just say is equal the sum, that's the function, then parentheses, and there's a couple ways to do this. I could give it the range of cells, or I could just use my cursor and just select the range of cells I want. So I want to sum all the numbers like that. I want to sum all these numbers, and I hit return, and I'm done. And I want to do the same thing over here. I want this to be equal to the sum of all of these numbers, and I'm done. Okay, and when I look at these two numbers, the inputs and the outputs, they're essentially the same, right? Within 3 significant figures, they're the same. And that's the condition of steady state that I needed to establish before I could use the residence time equation. Well, the residence time equation is really easy, right? It's just the volume divided by either of these numbers. They're the same. Remember, these are the total inputs or outputs in cubic meters per year. So the only thing I need to be careful of is that my volume also has to be in cubic meters. If I'm dividing the volume by meters cubed per year, the volume has to be in meters cubed. Well, this is actually turns out to be pretty easy. My lake, I was given the area in square meters, and I was given the depth, average depth in meters, and so the volume will just be the product of the area times the depth, and that will be in cubic meters. So in this cell H3, I've just multiplied, you can see what I did. I multiplied B3 times B4. I just multiplied the area times the depth. That is my volume in cubic meters. Notice I kept track of it in the label for that variable, so I know it's cubic meters. And the residence time for the lake is that's just poorly written there, isn't it? Let me try to fix this up. The L should be, and then okay. The residence time for the lake in years will just be that volume divided by either of these numbers, the sums, right? Because they're the same thing. So I just write the volume. It's going to be H3 I picked the inputs. I could have used the outputs. I get the same thing because they're the same number, right? And I end up with 1.16. And because the rate was in meters cubed per year, that's the time unit in the rate, or I'm sorry, the flux. Because the flux was in meters cubed per year, the residence time will be in years. If the flux was in cubic meters per day, then the residence time would be in days, but it was in meters cubed per year, so my answer, my residence time, is in years. And there it is, final answer. I'm going to highlight it, and let's give it bright red with yellow letters to make it garish so I can't miss it, and I'll make it bold, and I'll make it really big so that everyone goes, whoa, that's a really cool answer. How do I make it bigger? I don't even know how to do that. All right, there it is. Anyway, there's my answer. 1.16 years would be the residence time for the water in that lake.